So with the vector and scalar projections, instead of referencing our x and y axes, we're going to reference another vector. So it is basically asking the question, how much of the vector that we're interested in is acting in the direction of another vector? Okay, now with the scalar projection, it's only the magnitude or how much of it, whereas with the vector projection, vectors have got magnitude and direction, so we need to have direction in there as well. Let's have a look, the scalar projection of A on B. So we're going to let A equal 3i plus 4j, and I've already drawn my vectors in there to save a bit of time, and B is 6i minus 2j. So we're interested in how much of vector A is in the direction of vector B. And the easiest way to do that, and I'm not an artist, but you can imagine that this is a torch and I'm shining the light in this direction perpendicular to my vector B. And A would cast a shadow, that's meant to be a straight line, onto B, and that little vector there is the scalar projection of A on B. Now, in order to find that, I need to have a dot product of A with my unit vector of B. Okay, and the unit vector is the vector that's only 1 unit long. Okay, to find my unit vector of B, I need my magnitude of B, and so let's start with that. Magnitude of B, square root of x squared plus y squared. That's going to be the square root of 6 squared plus negative 2 squared, and that's root 40, which is 2 root 10. Then to find my unit vector, remember it's the one with the copy key, in the direction of B, it will be B divided by my magnitude of B, and that's going to be 6i minus 2j divided by, sorry, that should have been 2 root 10, divided by 2 root 10. And that means it's going to look like 3i over root 10 minus j over root 10. We need to rationalize those denominators. So that's going to be 3 root 10 on 10i minus root 10 on 10j. Okay, so I've got my magnitude and I've got my unit vector, and I can now find my scalar projection of A on B. So scalar projection of A on B is going to be A dotted with my unit vector B. And remember to find a dot product, x1, x2 plus y1, y2. A dot product is a scalar, okay? So we've got A dot B. So x1, y1 is my A, and my unit vector B is my x2, y2. Those are the two vectors that I'm finding the dot product of. So I've got 3 times 3 root 10 on 10 plus 4 times negative root 10 on 10, and that gives me 9 root 10 on 10 minus 4 root 10 on 10, which is 5 root 10 on 10, and that can simplify to root 10 on 2. Okay, let's have a look at the scalar projection of B on A. What that means is I need to change the position of my torch to see how much of B will shine onto A. So I'm going to draw my little torch perpendicular to A now. So this is perpendicular to A. And this is the vector that I'm interested in. Now, in order to find that, I'm going to need to find my unit vector in the direction of A. So again, our A is 3i plus 4j, and our B is 6i minus 2j. But now in this case, instead of finding the magnitude of B, we're finding the magnitude of A to find our unit vector in the direction of A. So here we've got 3 squared plus 4 squared, and that's going to be root 25, which is 5. And my unit vector in the direction of A is just going to be A over my magnitude of A, and that will be 3i plus 4j over 5, and we have 3/5 I plus 4/5 j. And therefore, our scalar projection of B on A is now going to have to be B dotted with the unit vector in the direction of A. So that means that my x1, y1 becomes my B, and my x2, y2 is my unit vector A. So that will be 6 times 3/5 plus -2 times 4/5, and that's 18/5 minus 8/5, which is 10/5, which is equal to 2.